Okay, now in this video I'm going to introduce you with some advanced IP addressing topic called subnetting. So you can see here, subnetting is the process of dividing one single network or one default network into multiple small networks. It is going to help in minimizing the size or the wastage of the number of IP addresses. Let us see how subnetting is going to do that. So to understand more why we need to divide the networks, let's try to take an example. In my company, I got some accounts department, I got some marketing department and sales and HR department. I got different departments in my company, and each and every department I got some 50-50 users, just an example, or maybe less than that or more than that. So around 50 users I have in each and every department. And my requirement is I want to ensure that all these departments should not communicate with each other. That's my requirement. Even though they are in the same LAN, same physical LAN, I don't want them to talk to each other. That's my requirement. Now to make that possible, what I can do is I can configure them in different networks, logically different networks. If I assign 192.168 one dot network, let's say I'm using a C class network, and I'm going to assign or use the 192.168 2 dot network for the second department, and I'll use 192.168 3 dot network, means 3.1, 3.2, 3.3, like that. And for the fourth department, I'll use 192.168 4 dot network. Now the difference is, now this is my C class network, and in case of C class network, by default there are three network portions: network, network, network. And in order to be in the same network portion has to be same, but here they are not same. So if it is not same, can they communicate with each other without a router? They cannot communicate with each other. Okay, so I'm making them logically in different networks so that they should not communicate with each other. But the problem is there is a lot of wastage of the IP addresses. So let's take an example. In the C class, by default, if you just get back, in the A class, by default there are around 16 million addresses in one network. That's what we have learned in the basic IP addressing. In the B class we have 65,536 addresses, and in the C class, in one network I can get around 256 addresses. So I'm using the smallest possible size, which is a C class as per the default network sizes, and I'm using just only 50 addresses in that particular 256, which means I'm not using around 216 addresses, 216 or 206 something. So similar way in the next department also, around 206 addresses I'm not using, 256 minus 50, 206 addresses I'm not using, and here also 206 addresses I'm not using. So if I count the number of addresses I'm not using, these addresses are simply wasted without use, because here my requirement is just 50, and if I go with the smallest possible size, whatever I have, so still I'm using a lot of addresses, still I'm wasting a lot of addresses. So there's a lot of wastage here. So what is the solution in this? Subnetting is a solution. But before that, let me go with one more example here. So one more example. Let's say you're working for some ISP now, and ISP is going to allocate the public IP addresses to different customers. So I got a customer A, customer B, customer C, and let's take an example on the customer A required some 10 public IP addresses. Now ISP got some public IPs from INA or authorized whatever the registry based on the region wise, and it has just take an example. I got some C class addresses from the registry, local registry, whatever it is, and every C class network supports 256 addresses. So now the requirement here is just 10 IPs. So is it possible to give all the 256 addresses to the customer, because he is asking for 10, and will the customer will pay for all 256? So both are not possible. So I cannot, you can see here I'm just using the smallest possible size, but this smallest possible size is not exactly going to meet my small requirements. So we have a requirement even much smaller than these things. So what's the solution we can do? So the solution is simple: divide one big network into multiple small networks, and then allocate to different departments. Like here in this example, what I'll do is I'm not going to use different networks here. I'm going to use only one network, and then I'm going to divide this one network into multiple small networks, and I'm going to allocate one small part to the accounts, one for the marketing, one small part for the sales, and one for the HR, like that. Okay, so we are going to divide them into small networks, and then we allocate them. Now this process of dividing a big network into multiple small networks, we call it as subnetting. Okay, so the main reason of doing the subnetting is, what we are doing is, whatever the default size we have, we are further dividing these networks into multiple small sizes, and as per our requirement. So we are dividing this network into multiple small sizes, but this time it will be as per our requirement or nearest to our requirement, and this process we call as subnetting. In today's networks, when you see any designing of your networks, probably you will see all subnetworks. You will see all the networks when we design, all will be of subnetworks only. Okay, so even you can take the example here, like you have a branch office here. Let's say I got a branch office in one location here, another location, like these are all different locations, and each and every location will have some different users, like 40 users here, 20 users here, 20 users here, 15 users here, and then 20 users here. Okay, so you just have only 40 users, and using one C-class network, complete C-class network in one location is not good thing, you know, because you got 256 addresses. In that you are just using only 40, remaining all addresses are simply wasted. So instead of doing that, what I can do is I can use one default network here, and I can divide that one default network into multiple small networks, and I can allocate this network here, this here, something like that. So that's what we do in the subnetting here. So we'll see more in detail how we do this complete thing in calculations. So I'm just giving you some basic overview on the subnetting here. So the next thing we need to understand, what are the different ways or different methods we do for subnetting. So there are two different methods we can do. We have something called FLSM, fixed length subnet mask, and we have something called VLSM, variable length subnet mask. Now the difference between these two is, I can represent in diagrams here. So if you are dividing the network into equal parts, we call this as FLSM. Now this is my FLSM, fixed length subnet mask, where each and every network will be of equal size. So all the networks will be equal size. So we call it as FLSM, just like your classrooms of any schools, colleges. So probably all the classrooms will be almost on equal size. Whereas VLSM, we are dividing based on, it can be equal, may not be equal. So VLSM, where we divide one network into variable sizes, may be equal, may not be equal, just like your, so variable sizes, just like your kitchen, bathroom, hall, bedroom, just like your home, where you have one network, you have 2 bedrooms of equal sizes, and then you got a big hall, and then kitchen, bathroom, something like that. You got a variable sizes, so something like that. So mostly in the production networks, most of the designs we have mostly like VLSM here. Majorly when we design the networks, we use VLSM, but FLSM is the foundations again. So that's the reason when we start calculations, probably we'll focus initially on the FLSM, and then once we understand, once we get the good foundations on FLSM, we'll move on the VLSM. So as I said, mostly if you have multiple branches, maybe you have some 40 users here, maybe you just have only 20 users here, or maybe just 10 users here. So the size varies in each and every branch or each and every department. So VLSM is the one which is most commonly used when it comes to designing the networks. So the next thing we need to understand is requirement, like how we do subnetting, based on what. So we do based on the requirement. Now here the requirement can be the host, the requirement can be the networks. Like when I'm allocating the number of users, when I'm designing a network, I'll see how many users or how many devices we need to connect, how many devices we need to connect in that, or how many users you want to connect. That is what based on the host. And the requirement can also be based on the networks, like how many departments you have or how many branch offices we have. Based on that, we divide them in multiple networks. So if you are calculating based on the host, we use this formula, 2 to the power of h minus 2 greater than or equal to requirement, where h is your host bits. And if you are calculating based on the network requirement, we use 2 to the power of n greater than or equal to requirement. Okay. So these are the formulas. We'll be using these formulas when we start the actual calculations in our next video. Okay, so in this video I'm just giving you some basic overview of what is subnetting and what we do in the subnetting. Now the final thing, what we do in the subnetting. In subnetting, we are going to convert our host bits, the default host bits, into network bits. Like if you just take an example, in A class we have one network portion and 3 host portions. That's what we have learned, right? Let me take it on a wide screen here. So in the A class, by default we have 1 network portions and 3 host portions, right? In the B class we have 2 network portions and 2 host portions, and in the C class we have 3 network portions and 1 host portions. So if you write them in bits, each portion is having how many bits? 8 bits. So if I write them in network bits and host bits, how many network bits and how many host bits? So network bits will be 8 and the host bits, it will be how many? 24. So 8 plus 8. And in the B class we have 16 network bits and 16 host bits, and in the C class we have 24 network bits and 8 host bits. So this is the default bits table we have in A class, B class and C class. So I'm going to take a C class example, 24 network and 8 host bits, because there are 24 network bits, which means there are three network portions and 1 host portion we have. So this is the default tally of network and host in case of C class. Now this default tally of 24/8, once we do subnetting, it can change to 26/6, or it can change to 27/5, or it can change to 30/2, or it can change to 28/4. So what exactly we do here is, some of the host bits here, you can see there are 6 means, whatever the remaining 2 gets converted into network. So we are reducing the number of host bits. In subnetting, we are going to reduce the number of host bits. So reducing the number of host bits automatically reduces the size of the network. Now to reduce the number of host bits, we are just converting them into network. So which means by default there are 8 host bits. So what is the size of the network? 2 to the power of 8, 256 is the size of the network. When I change it to 6, it becomes 2 to the power of 6, 64 will be the size. So when I change to 4, 2 to the power of 4, it will be 16 is the size of the network. So we are reducing the size of the network by reducing the number of host bits. What exactly, where the remaining bits will go? They go into network. There were 24 by default, now it becomes 28 because of 4 gets converted. Now same way here also. So that's what exactly happens in the subnetting. When I say we are doing subnetting, means we are not doing much calculations. In fact, we are doing some calculations, but we are just changing these bits and we are converting them into network. So we are customizing the things. So that's what we call as subnetting. We are customizing the bits based on the size what we require, and this process we call as subnetting. So we'll be getting into some more in detail calculations step by step as we go ahead with more and more subnetting calculations in the next videos.